Last learning target, we introduced the basic parent function of a quadratic. Today we're going to talk about moving that basic function around the grid. So instead of just having a vertex right here at 0, 0, oh, let me make my pen working here. Instead of just having every graph start here in the middle, we're going to start talking about where graphs can start here or somewhere else on the grid. Okay, so we're going to talk today about moving left and right and up and down. So the first kind of translation or movement we're going to talk about is vertical. So a vertical translation is a shift up or down, right? Because a vertical line looks like that, right? It's an up and down line. So a vertical translation is a shift up or a shift down. Okay? So take a look here. The graph y equals x squared plus k. So we're going to start talking about equations that have a plus a number at the end of it. That is a graph of the parent function moved up or down. So let's go ahead and graph the parent function, which remember is this y equals x squared. And we're going to graph that, and then we're going to graph the other one and show how it moves. So y equals x squared should be something we memorized, right? We're just squaring x, so negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, and then mirror it back up. Okay, this is a function we should be able to graph pretty easily. So one way that I memorize how to graph the parent is I always start at the middle, then I go over 1, up 1, over 1, up 1. Then I go over 2, up 4, over 2, up 4, and then over 3, up 9. I have that pattern memorized. That's always going to be true for the parent. Okay, now I'm going to go ahead and connect these. There's my parent function right there in purple. All right, that's my basic y equals x squared. Now I'm going to go ahead and graph this, y equals x squared plus 2. Okay, now I could do this in my calculator, but when you're adding 2 to x squared, you're really just taking this 9 and saying let's add 2 to it to get 11. Let's add 2 to the 4 to get 6. Let's add 2 to 1 to get 3. Add 2 to 0 to get 2. And so on. Okay? So we're adding 2 to x squared. All right? And if we were to take our calculators, which of course you're always more than welcome to do, and we were to type into here x squared plus 2 and get the table, you're going to see that it's going to give you the same points I just got. 11, 6, 3, 2, 3, 6, 11. So either way, whatever how you want to think about it. But I do want you to realize that, you know, when you take the parent and add 2, you're just taking the y values and also adding 2 numerically. So let's see what this graph is going to look like. So here are my new coordinates, negative 3, 11, negative 2, 6, negative 1, 3, 0, 2, 1, 3, 2, 6, and 3, 11. So let's graph these points. So negative 3, 11 is right here. Negative 2, 6 is here. Negative 1, 3 is here. 0, oh, sorry, that's not 3, that's 2. There's 3. 0, 2, 1, 3, 2, 6, and 3, 11. So you're going to notice, as I draw this parabola very carefully, you're going to notice that the shape is exactly the same, and you're going to see that, look, all it did was move up 2 units, right? And that makes sense because we have a plus 2, it's going to move the vertex up, okay? So when we have a plus or minus, we're moving that vertex, okay? So the new vertex for this equation is going to be 0, 2. That's my new vertex. This is a minimum. The vertex is a minimum because the lowest point is right here. And then the axis of symmetry is still x equals 0 because when we draw a line down the middle, even though the vertex changed, this is still going through 0 for the axis of symmetry. Okay? Let's try another example where instead of adding something to x squared, we're now subtracting something from x squared. So again, we're going to graph, what color did I use for the original? I used purple. Okay, so we're going to graph the parent again. Remember my 9, 4, 1, 0, oops, sorry, 0, 1, 4, 9. Remember, I graphed that by doing 0, 0, over 1, up 1, over 1, up 1, over 2 up 4, over 2 up 4, over 3 up 9, and over 3 up 9. The more you do this and graph the parent, the more you will memorize it, and it won't become something you have to put on your calculator anymore. That's the idea here, okay? Now, let's graph x squared minus 5. So like before, I'm just doing, oops, the color didn't change. I'm just going to do minus 5 for each of these. What is my pen doing here? Sorry guys, my pen is being kind of crazy. Alright, minus 5 to get 4. 4 minus 5 gives me negative 1. 1 minus 5 gives me negative 4. 0 minus 5 gives me negative 5. 1 minus 5 gives me negative 4. 4 minus 5 gives me negative 1. And 9 minus 5 gives me 4. Okay, so you can see I've still got the mirror effect with these new values, right? This negative 5, then it goes out. So now let's graph this new set of coordinates. So my new set of coordinates is negative 3, 4, negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, 2, negative 1, and 3, comma 4. Right? You could also get this from your calculator or table, but I'm trying to show you that a vertical shift is just subtracting from the x values. Okay? So let's plot these points. Negative 3, 4, negative 2, negative 1, negative 1, negative 4, 0, negative 5, and then I'm just going to mirror the others here, like that. And when I graph this, notice what happened from x squared to x squared minus 5. It now went down 5 units, right? 1, 2, 3, 4, 5. And now it has a new vertex at 0, negative 5, right? So when we subtract something from the x squared, we're just moving it up and down is the idea. It is still a minimum, and its axis of symmetry is still that through the x-axis here, right? So it's still going to be x equals 0. Okay? So that's vertical up and down shifts when we move the vertex. The other type of shift we have is a horizontal shift, and this one's a little trickier. The way the math works, it's not as simple as the tables we created before. So a horizontal translation is kind of the opposite of a vertical translation. A horizontal translation means we're let me use the word shift. It is a shift left or right. So remember, a horizontal line looks like this. The horizon of the sky is flat, so horizontal means left to right, okay? And when we want a horizontal shift, we're going to look at something like this. So take a look at this equation. This one's a little different, right? And with the k, when we had before, here's the equation we were working with before. Let me go back. We were working with this guy right here. See how the k is outside, the x squared kind of tagged onto the end? And in this equation, it's put inside the parentheses. So that's a really big difference between a horizontal and vertical. The horizontal's inside the parentheses and the vertical's outside the parentheses. So when I see this graph, I want us to graph this function here, and I'll use a different color to make this more clear. I want to graph this right here. I'm going to go ahead and put my parent values down. I'm going to graph that first on my grid. So I'm going to, do my normal parent, over 1, over 1, over 2, up 4, over 3, up 9, and there's my parent. Okay, so there's my basic y equals x squared. Okay, now how do I get the values for this x minus 2 squared? I'm not just going to subtract 2 here, because if I just subtract 2 here, I'm not including the squared part. So whatever number I subtract 2 from, I also have to square it, which is kind of a strange concept. So my recommendation for getting points for the horizontal shift, just to show you right now, is we're going to put it in the calculator, okay? Just so we can get that list without having to kind of make some numerical mistakes. So I'm going to go ahead and go back to my y equals, and I'm going to put parentheses x minus 2 parentheses squared. See how I've put that in parentheses and I put the squared at the end, and then I'm going to get my table. Okay? Now, I'm going to go ahead and plot that 0. I'm going to go ahead and write down that 0, 4 here. So I've got 0, 4. Then I've got 1, 1. I've got 2, 0, 3, 1. And then negative 1 is 9. Negative 2 is 16. And then negative 3 is 25. Now, this table looks a little strange because normally I have the mirror, the vertex right here. But as I start plotting points, you're going to see that it's going to shift, okay? So I'm going to plot this 0, 4 first. So there's 0, 4. Let's plot the 1, 1. In fact, let's write these out here to help us. This is 0, 4. This is 1, 1. This is 2, 0. This is 3, 1. This is negative 1, 9. And these I'm not going to graph because our grid doesn't have it on there. Okay, so we're just going to graph these 5 points. So 0, 4, negative 1, 9, 1, 1, 2, 0, and 3, 1. So notice that I've got these points here, and as I start to graph them, I notice that I start to curve here, right? Well, if I use my axis of symmetry, and this is actually a very cool thing, and I draw it down the middle, I'm going to create a little mirror for myself. So that point is 1 unit away from that point. Here I've got them 2 units away, so I'm going to make another point 2 units away. And this point up here is 3 away, so I'm going to go 3 away on the other side of the axis of symmetry. And then I can get my other points for my parabola. So that's one way to get additional points. Now look at how this graph moved. Instead of going up and down, it moved 2 units to the right. So that vertex just moved 2 spaces to the right, which is why we have this -2 here. Okay, now the weird part, and this is what's going to be a struggle for this learning target, is that when you see this minus sign, a lot of you are going to think to move left. But actually, the minus sign means move right, which is really challenging to remember. Okay, so my new vertex is now 2, 0. It is still a minimum, but my axis of symmetry is now different. Remember, your axis of symmetry is always x equals whatever your x coordinate is in your vertex. So it's x equals 2. That's that yellow line I've drawn down the middle. That's your axis of symmetry. Okay? So now let's see what we have when we have a shift left. So I'm going to go ahead and put in my parent function. Let me do that in purple again. So I've got 9, 4, 1, 0, 1, 4, 9, like always. I'm going to go ahead and plot that. Over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, over 3, up 9, over 3, up 9. There's my parent. Same as always. Y equals x squared. Now I have x plus 2 squared. So my gut is telling me that, look, before I even make the table, I know that this is going to be a move left because it's positive, and we just found out that a negative means move right. So I'm going to go ahead and test myself here. I'm going to go ahead and put a vertex right here on that point right there because I can see that that is exactly 2 units away. Okay? Now, I'm going to go put in my calculator this equation just to make sure that I'm doing it correctly and that I do end up getting a point at -2, 0. So let's go ahead and put in this graph. So instead of x minus 2, I'm going to have x plus 2. So that's what I have in my calculator now. I'm going to get my table, and if I did this right, oops, I hit graph, sorry. To the table. Look at that. I've got a point right here that I've highlighted in black of -2, 0. So there is some logical connections we're making here. So this is going to be -2, 0. This is going to be -3. That's going to be 1. Oops, sorry, guys. -1, 1. 0, 4. 1, 9. And then this will be 16 and 25. But we won't use those because we don't have them on the grid. Okay? So now I'm going to plot my other points. Now here's another little trick we can do. If I know that my parent function goes over 1, up 1, this guy is also going to go over 1, up 1, over 1, up 1. It's also going to go over 2, up 4, and over 2, up 4, and it's also going to go over 3, up 9, and over 3, up 9. Now I could confirm that by seeing these points. Look, 1, 9, 0, 4, negative 1, 1, negative 3, 1. All these points will match that pattern because all I've done is just shifted all of the points. In fact, if you draw a little black line here, you'll see that every point is actually 2 away, right? There's all of the shifts. We've shifted all of our points 2 to the left. That's how a horizontal shift works in a quadratic, and this is what the function for it looks like. All right. My new vertex is now negative 2, 0. Still a minimum, though, because all of these graphs are pointing up. And my axis of symmetry is now x equals negative 2 from that line that goes to the middle. So now, with what we've learned from shifts, we can graph these really easy without a calculator. Now, again, I'm not going to make you, and I can't track whether you use a calculator or not, but I would like you to maybe make your lives a little easier and try and remember that the parent will help you. So when I see this x squared plus 4, this means it moves up 4. So I'm going to move my vertex, 1, 2, 3, 4. There's my vertex. Now I'm just going to draw the parent function. I know it goes over 1, up 1 for the first 2 points. It goes over 2, up 1, 2, 3, 1, 2, 3, 4 for the next 2 points. Okay, and the other points I can't graph because it's not the graph's not big enough, but 5 points is enough, so I know my graph is going to look like this. That's why the parent function is so nice to memorize. You don't have to use a calculator, plug in points, you just memorize the pattern of over 1, up 1, over 2, up 4, over 3, up 9 from the vertex. Okay. This next one is similar, but now I'm going to move down 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. There's my new vertex. Over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, over 2, up 4. And this one does have room for the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 9 over here. So that guy did have room. And there's my new quadratic of x squared minus 7. All right. Now we've got 2 that do left and right shifts. Now remember, if it has a minus sign, that is a shift to the right 3. Okay, I know that's weird, it's minus, but it's the opposite that your brain thinks. A negative 3 inside means actually move to the positive right 3. So I'm going to keep my vertex here at 3, 0, moving it to the right 3, and then my up 1, over 1, up over 2, up 4, over 2. Oh, this grid is counting by 2s. That's very interesting. Let's change this grid. I want this to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Though I don't want them going up by 2s. Alright, so my vertex is going to start at 3 here, over 1, up 1, over 1, up 1. Then it's going to go over 2, up 1, 2, 3, 4, over 2, up 4, and over 3, up all the way to 9 here and here. So there's my shift to the right 3. And then finally, this last example here, we're going to shift to the left 3. So now my new vertex is here. I'm going to relabel. I don't know why this grid is like this, guys. I'm sorry. We're just going to redo it here. So it's 1, 2, 3, 4, 5, 7, 8, 9, and 10. Easy fix. Okay, so shift to the left 3, and then over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, up 1, 2, 3, 4, and that's 5 points is enough to get the idea here. Okay? So this is how shifting works. Okay? Now, I want to introduce you to combining left and right shifts and up and down shifts into one whole equation. And we call this, form, oh my gosh, what's happening? There we go. We call this form, we call it vertex form. So this guy right here is called vertex form. And it's a combination of shifts vertical and it combines shifts horizontally into one equation, okay? So I've still got my shift left and right, which is right here. That's this part inside. I've still got my shift up and down, which is right here. Okay, so I'm moving it left and I'm moving it up. Okay, So let's take a look at some of these examples. Remember, A still stretches or shrinks, just like in the last learning target. I've got my A right there in front. And then the sign of A still determines concave up or down. So that hasn't changed since the last learning target. A still means that. So when I look at this first problem, I'm going to look at my A first. My A is -1/2. That's my A right here. Boom. That is a concave down because it's negative, and it's a stretch because I've got that fraction. Okay? Now to find the vertex is how we shift left or right. Okay? So when I make my vertex, the H, this number right here, is actually what's going to go in my X spot, and then this number, which happens to be 0 in this example, is going to be my K. Okay, and remember, my vertex is H, K. So I see that I've got a 4 here in the middle. That means I'm going to shift the left 4 on the x-axis, and then I'm not going to shift anywhere on the y-axis, right there. Okay, so the vertex is really your shift. And another way to think about it, actually, which I think is kind of interesting, if you have this H, K, then whatever number goes here is your shift left or right, and whatever goes here is your shift up or down to create that vertex. Okay? Alright, the second problem, take a look at your A. A is invisible 1 right here. So it's going to be concave up because that's a positive 1, and it's not going to have any stretch or shrink because A doesn't change. My vertex, it's going to have a left and right shift of -3. Remember, we take the opposite, so this is actually a shift left 3 because it's a plus. And then this right here is a shift down 1. So my vertex is -3, -1. All right? Let's draw a line here because this is kind of jammed these too close together here. Sorry about that. All right, the next problem, look at your A first. That is a -1. So that negative means it's concave down. Because it's 1, there's no stretch or shrink. Okay? And now my vertex, I'm going to shift the left 1, so it's -1, and I'm going to shift up 4. So my vertex is -1, 4. And finally, my last one right here, A is -4. That's going to be concave down because it's negative. It's going to be a shrink because I've got that 4 there. That's going to be a really skinny guy. The bigger that number gets, the skinnier it gets. And my vertex, be careful with your signs here because it's all 4s, so really the signs matter. This means it's a shift to the right 4, opposite sign, and this means it's a shift down 4, keep the same sign. So for when you write your vertex, the X you change the sign, the Y you keep the sign. Okay? Alright, so now let's combine all of this together into graphing a function in vertex form. Okay? So before I put this in my calculator, I'm going to go ahead and get some information first. So from this graph, I can see that it's going to be concave down, because that's my A is -3, and it's going to be a shrink because that's a 3, not a fraction. Now I'm going to find my vertex, so I'm going to have a vertex, a shift left 1, because there's my 1, and then I'm going to have a shift down 2, so my vertex is -1, -2. My axis of symmetry, I always know my axis of symmetry is going to be x equals whatever this guy is every time. So this actually really helps me put it in my calculator because I know where the vertex is right away. So when I put this in there, I can scroll to those points to find where I want to graph my other points on this grid. And I'll show you what I mean in a second. So let's go ahead and put my vertex. See this table right here? The vertex should go in the middle. So I'm going to put -1, -2 right here, and I'm getting that from this right here. I'm going to go ahead and put that in the middle of the table, because in a parabola, your vertex is right in the middle, right? I'm going to go ahead and plot that point. That's right here. There's -1, 2, and I'm going to draw in my axis of symmetry. You don't have to do this if you don't want to. I think it helps, but it's your call whether you want to draw that in there or not. It's completely optional. So now when I go to my calculator and I type it in, let me turn it on here, and I type it exactly like it looks, -3, -3 parentheses, x plus 1 parentheses, put the squared there, and then -2. And now we're going to hit our table. Now, here's where the part that helps with your table. Do you see how the vertex is at -1, 2? So when you plot your other, values into this table, put them around it. So I would make this 0 and then 1, and I'd make this -2, -3, right? That's how the number line goes. And now I would go to my table and look for those pairings. So 0 goes with -5 in my calculator. 1 goes with -14. Oh, I keep hitting that. -14. -2 goes with -5, and -3 must go with -14. So do you see how I've created that mirror by finding the vertex? Where if I didn't have that, I might have some trouble maybe finding the vertex right away. So the vertex should be something you can find really easily without your calculator. Alright, so now when I plot these points, I've already graphed that one. Let's do 0, -5. In fact, that is hard to see, so I'm going to erase that for now. 0, -5, 1, -14, and then there's just going to be a mirror here of these points right there. So do you see how skinny that is? It's really skinny. Okay, and does it match what I thought? Is it concave down and was it a shrink? Absolutely, and I could tell all that information from the equation. Okay, which is why equations are so valuable. We can tell a lot just by looking at this equation. Okay, let's try one more here. Okay, is this going to be concave up or concave down? Well, there's my A. That's going to be concave up because it's positive. It's going to be a shrink again because it's a 2, not a fraction. And now my vertex are these two guys right here. That's my vertex. I changed the sign of the one inside, so it's going to be a shift to the right 1, so make that positive, and then a shift down 7. My axis of symmetry is x equals 1. It's always x equals whatever that x value is in the vertex. Now that I know my vertex is 1, -7, that goes in the middle. I know this is going to be 3, and then I'm going to go backwards here, just like a number line. Now when I plug this into my calculator, I'm going to go to y equals, clear this out, 2 parentheses x minus 1 parentheses squared minus 7, get my table, and now I'm going to go right to the number 1 here on my thing. You can always scroll up and down. So then I see that it's -5 on either side, and it's going to then be a positive 1 after that. Okay. Now I just need to plot these points. So 1, -7 is here, 2, -5. Oops, sorry, I graphed that point wrong. I was like, what? All right, 1, -7, 2, -5, and 3, 1. And then it's just mirrored on this side over here. Okay. And there we have our parabola. Make sure you draw your arrows and make sure you always have, guys, at least 5 points. I will not take it. It will be wrong if it has only 3. I won't do it. Okay? And finally, this last question, how can you tell from an equation whether the vertex is a maximum or minimum value? Well, if something is a maximum, if a vertex is a maximum, then it's got to be concave down, right? And if a vertex is a minimum, then it's got to be concave up. And we get to tell that from the A value. So if A is positive, then it's going to be a minimum. If A is negative, it's going to be a maximum. Okay? So we're really trying to make these connections, guys, thinking about how these quadratics move and what we can really pull from the equation and not just depend on our calculators. Use those calculators to help you, but I am going to be able to, I'm going to quiz you and test you on whether you can find this information without it. Okay, so, take your practice seriously, ask for help, and thank you for your time with this video. I know it was a long one.